Hi students, welcome to lesson 5.7, interpreting graphs of linear functions. Alright, so here's a graph that represents this situation. So a float plane, so planes that land on water, fly into lakes in Canada's northwestern wilderness area for ecotourism. Alright, so this graph shows the height, so this is the height of a float plane above the lake as the plane descends to land. So this is time, and that's how long it takes. So obviously to travel that distance, it doesn't happen instantly. So over a 10-minute period, it starts at its highest point, which should be 1,000 meters, so it'd be a kilometer height, and it slowly goes down to the water and reaches the water at time equals 10 minutes. All right, well, let's interpret this graph a little bit. So where does the graph intersect the vertical axis? Okay, so notice this line crosses the vertical axis at 1,000. Okay, what does this point represent? Well, this is the point at time 0, so probably at its highest point. This is the highest point of the plane. So the plane would have flown at 1,000 meters, and all of a sudden it decides to land, so then it would slowly start descending. All right, so maybe I'll write that down. Where does this point represent? So this would be the highest point of the plane. And we're going to say h is equal to 1,000 meters. All right, where does the graph intersect a horizontal axis? So it intersects a horizontal axis at t equals 10. As I mentioned, that would be when the height is 0. Therefore, that's where the plane would have landed. Okay, so that's t equals to 10, and that's the time the plane landed. And what is the rate of change of this graph? So if you look at it, and we can just simply do triangles going back and forth. So it goes down 100 meters in 1 minute, goes down 100 meters in 1 minute, 100 meters a minute, 100 meters a minute. So it would be negative 100 meters per 1 minute. Okay, and this relates to basically negative 100 over 1, which just means that you're going to go down, you're going to lower 100 meters, the plane's going to go down 100 meters every single minute. Alright, so in the last example, state the domain and range of the rate of change of this function. Okay, so the rate of change as was written, this is negative 100 meters per 1 minute. Okay, so that was the rate of change. Now the domain, if you looked at it, since domain is t in this case, we had the time between 0 and 10 minutes. So the domain in set notation would be t is larger than 0 but smaller or equal to 10. The interval notation, that would look like 0 to 10. Okay, for your range, okay, so the range would be all the possible values of the height. So the height would have traveled anywhere between 0, that's when the plane landed, and 1,000 meters, where the plane started at its highest point. Alright, in the interval notation, again, this would be a 0 to 1,000. So are there any restrictions on the domain and range? Explain. So the ideas are, for the domain, so the values of t, okay, time cannot be negative. So t cannot be negative. Okay, if we went back, you would have to consider time starting earlier. So t cannot be negative, and we're going to stop counting after the 10 minutes when it landed. Okay, so that's kind of the restrictions on the domain. For the range, the restrictions are, well, the highest point, so h has a highest point, the plane's got a height maximum. So plane has a height maximum. Oops. Okay, so plane has a height max, which would be 1,000 meters in this case, and has a minimum, So it has a minimum of 0 meters because when it lands, it can't go into the ground, so the height would be 0 meters. All right, so now identifying intercepts. Intercepts are when it crosses the x and y axis. So in this case, the x-axis is time, and the y-axis is temperature in Celsius. Okay, so the intercepts are when it crosses these lines. So it's basically when either one is equal to 0. So when time equals 0, the temperature is -6 degrees, right? So that would be -6 over here. Okay, so when time equals 0, the temperature is -6 degrees. When the temperature is 0 degrees, right, that would be time is 4 hours, which means 4 o'clock, let's say. Okay, so this is a graph that represents probably something like midnight. It's -6 degrees. By 4 a.m. it's warmed up a bit to 0 degrees. By 8 a.m. it's warmed up to 6 degrees. And by noon it's all the way warmed up to 12 degrees. So we call this a linear function because it's increasing at the same rate, right? So every 4 hours we're going up 6 degrees. 4 hours, 6 degrees. 4 hours, 6 degrees. All right, finding intercepts algebraically. So now if I want to find them using an equation, all we have to do is to find the y-intercept, you substitute x equals 0. Because think about it. This is the y-intercept, right? The value of x is 0 here. In this case, it's time. Okay, so the coordinates of this point right here, right, that would be the point 0, -6. The coordinates of this point over here would be 4, 0. So all the x-axis, on the x-axis, all the values of y equals 0. On the y-axis, all the values of x equals 0. So all we need to do is substitute x equals 0 into the equation and solve for y. Okay, so you evaluate f of x when x equals 0, and that is evaluate f of 0. So let's look at just a quick example. Let's say you had f of x equals to 2x minus 5. Okay, so f of x represents your y value. So all I'm doing to find the y-intercept is I'm plugging in x equals 0. So f of 0, so I'm replacing x with 0, equals to 2 times 0 minus 5. So f of 0 equals to -5. Okay, so that's pretty simple. Now to find the x-intercept, we substitute y equals 0 into the equation and solve for f of x. So again, I'm going to say f of x equals to 2x plus 5. Okay, so now I'm saying that y is equal to 0. So I'm saying that f of x equals to 0. Again, this is the representation of y. So we are saying that y is equal to 0 equals 2x plus 5. And I'm going to solve for x. So minus 5, you get 2x, you divide by 2 equals x equals -5 over 2. So this would be your x-intercept. Okay, so now sketching a function using intercepts. So let's sketch this one using intercepts. So basically let's just find 2 points, and we know it's a linear function because it follows the shape of y equals to mx plus b, and this is an intercept and this is your slope. So in this case, let's find our 2 intercepts. So for the y-intercept, okay, so this is when x equals to 0. I'm going to plug in x equals 0 into the function, so -2 times 0 plus 6, which gives us 6. Okay, so f of 0 equals 6. So we have a point on the graph when x equals 0, y equals to 6. That's our point. Okay, so now for our x-intercept, again, that's when y equals to 0. Okay, so I'm going to plug in y equals 0 and then solve for x. So you bring the 6 over on the other side, you get -6 equals to -2x. Divide by -2 both sides, you get x equals to 3. So on our graph here, you plug in x equals to 3 when y equals 0. Sorry, that's not a very nice point. Let's try that again. Okay, put that point there. And now all you really need to do is put a line through them, right? So you have this line. I'm going to try to be as precise as possible here. Okay, so there's our line using 2 points, the 2 intercepts. All right, lastly, let's sketch a graph of a linear function. So you can obviously sketch this using the intercepts, as we said earlier, but you could also sketch it using y equals to mx plus b. So this is the form, so right here, this is the form y equals to mx, whoops, that's not an x, mx plus b. Okay, so the b here in this case would be -3. The m here is your 6. F of x is your y, x is obviously x. Okay, well the m over here represents your slope. That's your slope. That's how much you go up or down every single value of x. So this is the rate of change, if you look back on what we did before. B, well that's simply your y-intercept. Because whenever x equals 0, this value goes away. All you're left with is y equals to that value. So whenever x equals 0, the y-intercept is b because it's just y equals b. All right, so let's take a look at that. In this case, b is equal to -3, which means our intercept is -3. Okay, and our slope here, so our slope, so maybe I'll write it in our case. So in our case, m is equal to 6 over 1. Don't forget, when you talk about a slope or a rate of change, it's always a fraction. You're always saying, okay, how much is it going up? And then how much is it going over? And then b is equal to -3. Okay, so for m is equal to 6 over 1. So that means for every x value here, you're going to go up 6. So you're going to go up 6 over 1. Up 6 over 1. So the points you could create would be up 6, so you're at -3, over 1, so you're at 1, 3. And then you're going to do it again. You're going to go up 6, you're at 3, go to 9, over 1, which is 2. Okay, and then from that point, all you got to do is put a line through them all. Okay, so I don't have a ruler on me. Sorry, guys. I'm sure you guys can do better with a ruler. Okay, so now the only thing I'm going to check is, well, let's make sure the graph's good. So let's find, I already know the y-intercept is -3. I plug in x equals 0, that's -3. What happens if I find my x-intercept? So my x-intercept is somewhere in between 0 and 1. If you guys can figure out it's exactly a half, then that's great, because you go over 1, you go up 6, that's exactly halfway point. I'm going to plug in y equals 0. So I'm going to plug in y equals 0. So you have 0 equals to 6x minus 3. And I'm going to solve for x. So bring the 3 over and then divide by 6. You obviously get the half, right? So that point would be a half. So this value corresponds to the graph we've drawn. All right, guys. Hope you like that lesson, and good luck in class.